A turn is a unit of plane angle measurement equal to 2 pi radians, 360 degrees or 400 gon. A turn is also referred to as a revolution or complete rotation or full circle or cycle or rev or rot. A turn can be subdivided in many different ways, into half turns, quarter turns, center turns, milliturns, binary angles, points etc. Subdivision of turns. A turn can be divided in 100 center turns or 1000 milliturns, with each milliturn corresponding to an angle of 0.36 degrees, which can also be written as 21 feet 36 inches. A protractor divided in center turns is normally called a percentage protractor. Binary fractions of a turn are also used. Sailors have traditionally divided a turn into 32 compass points. The binary degree, also known as the binary radian, is 1/256th turn. The binary degree is used in computing so that an angle can be represented to the maximum possible precision in a single byte. Other measures of angle used in computing may be based on dividing one whole turn into 2n equal parts for other values of n. The notion of turn is commonly used for planar rotations. Two special rotations have acquired appellations of their own. A rotation through 180 degrees is commonly referred to as a half turn. A rotation through 90 degrees is referred to as a quarter turn. A half turn is sometimes referred to as a reflection in a point since these are identical for transformations in 2 dimensions. History. The word turn originates via Latin and French from the Greek word tau omicron rho nu omicron sigma. In 1697, David Gregory used pi rho to denote the perimeter of a circle divided by its radius. However, earlier in 1647, William Orchard had used delta pi for the ratio of the diameter to perimeter. The first use of the symbol pi on its own with its present meaning was in 1706 by the Welsh mathematician William Jones. Euler adopted the symbol with that meaning in 1737, leading to its widespread use. Percentage protractors have existed since 1922, but the terms center turns and milliturns were introduced much later by Sir Fred Hoyle. The German standard DIN 1315 proposed the unit symbol PLA for turns. Since 2011, the HP 39GII and HP Prime support the unit symbol TR for turns. Mathematical constants. 1 turn is equal to 2 pi radians. Tau proposal. In 2001, Robert Paley proposed using the number of radians in a turn as the fundamental circle constant instead of pi, which amounts to the number of radians in half a turn, in order to make mathematics simpler and more intuitive, using a pi with 3 legs symbol to denote the constant. In 2010, Michael Hartle proposed to use the Greek letter tau instead for 2 reasons. Second, tau visually resembles pi, whose association with the circle constant is unavoidable. Hartler's tau manifesto gives many examples of formulas that is simpler if tau is used instead of pi. Examples of use. As an angular unit, the turn or revolution is particularly useful for large angles, such as in connection with electromagnetic coils and rotating objects. See also winding number. The angular speed of rotating machinery, such as automobile engines, is commonly measured in revolutions per minute or RPM. Turn is used in complex dynamics for measure of external and internal angles. The sum of external angles of a polygon equals 1 turn. Angle doubling map is used. Pie charts illustrate proportions of a whole as fractions of a turn. Each 1% is shown as an angle of 1 center turn. Kinematics of turns. In kinematics, a turn is a rotation less than a full revolution. A turn may be represented in a mathematical model that uses expressions of complex numbers or quaternions. In the complex plane, every non-zero number has a polar coordinate expression z equals r/c is equals r cos plus reason, where r greater than 0 and a is in 0, 2 pi. A turn of the complex plane arises from multiplying z equals x plus iy by an element u equals zb that lies on the unit circle. ZUZ. Frank Morley consistently referred to elements of the unit circle as turns in the book Inversive Geometry, which he co-authored with his son Frank Vigor Morley. The Latin term for turn is versa, which is a quaternion that can be visualized as an arc of a great circle. The product of two versas can be compared to a spherical triangle where two sides add to the third. For the kinematics of rotation in 3 dimensions, see quaternions and spatial rotation.